So now we're going to get into two-dimensional motion in these problems here. And we're going to start off with vector addition just in general. So number one, find the following path for A in this figure. All right. The total distance traveled and the magnitude and direction of displacement from start to finish. Okay, so for distance traveled, so in 2 dimensions now we can move up, down, left, right. And so when we're doing total distance traveled, sorry, let me turn on the. When we're doing the total distance traveled, we're looking at this segment. It goes this. So from A, he's going to start from here to here, and then it goes here to here. So let's see. All blocks are 120 meters on the side. So it goes 1, 2, 3 blocks. So he goes up 360 meters this way, right? Because it's 3 times 120. Let me rewrite that as 360 meters. And then it goes over 120 meters. So the distance traveled is you just sort of add along the path. So the distance traveled is 360 plus 120, and that's 480 meters. Okay. So that is the distance traveled. I always try to overwrite it, but it just doesn't look good that way. So 480. B, the magnitude and direction of displacement from start to finish. Well, when we do vector addition, when you think of the vector, you draw a vector from the start to the end. So we're going to draw a vector that looks like this. Imagine I drew a straight line there, though, and it's not so curved. Okay, so that's the straight line between from the start to the finish. This is the vector. One, we want to calculate the length of this vector. So the length of the displacement vector, delta x, this time we'll call it as a vector. Well, to find the magnitude, we can use the Pythagorean theorem, right? This would have to be the square root of this squared plus this squared. 120 squared plus 360 squared. Squared equals 379. Okay. How do we decide the direction? There's a couple of ways we can do the direction. We can do either, typically we measure direction, a common way is from the easterly direction or the positive x-axis. So we measure this angle here. Okay, this angle here is the same as this angle right here. That makes sense. Okay. You could also do the angle relative to north, but I'm going to do the angle relative to the east direction because that's just normally how we do it. So this angle theta, because these are interior angles of 2 parallel lines, so these angles are equal. So how do we know what this angle is? Well, I can use trigonometry to tell you that the tangent of this angle would have to be opposite over adjacent, right? Opposite would be 360 over 120. And thus theta would have to be the inverse tangent of 360 over 120. Okay, if I do trig tan inverse of 3, I get 71.6 degrees north of east is how we would describe this. Or, like there's a lot of ways you can describe it. Just basically 71.6 degrees relative to the horizontal axis there. Okay, so for number 3, find the north and east components of the displacement hikers for the one shown in figure 3.52. And I realize I do not have figure 3.52 on here. And so I just assumed it would be the same figure, but it is not. So we will not do that problem because figure 3.52 is, I don't have it right here in front of me. So that's fine. We don't need to do that problem. Let's look at number 5. Suppose I first walk 12 meters in the direction 20 degrees west of north. So they have a picture here. And then 20 meters in a direction 40 degrees south of west, like that. How far are you from your starting point? And what is the compass direction of the line connecting your starting point to the final position? Parentheses, if you represent the 2 legs of the walk as vector displacements A and B, then this problem is to find their sums. There's actually a couple ways to do this one. I find the most straightforward way when I do these physics problems is I always break it into the horizontal and vertical components, and I simply add them up. Okay, so if I wanted to say break this vector into its vertical and horizontal components, I'm going to say, I'm going to have a vector north here and a vector west here. And then for this vector, we have a vector west here and a vector south here. Okay. Now, how do I know what each of these components of the vectors are? Is I look at, I would know that, for example, the sine of 20 degrees would be this opposite side. We'll call this like opposite, would be equal opposite over 12, the hypotenuse. So this opposite side is 12 sine 20 degrees. So this is a common way you want to kind of think of this. The opposite side is going to be the hypotenuse times the sine, because sine is like opposite over hypotenuse. So we say this is 12 sine 20 degrees. This side is 12 cosine 20 degrees. This side is, think of this, so if I look at the 40 degrees, the hypotenuse is 20. This side here is the adjacent side. So this side is 12 cosine of 40 degrees. And this one is the opposite of the 40 degrees. So this one is, not 12, sorry, 20. And this part is 20 sine 40 degrees. Now, if I look at the resulting vectors, what you can do is you sum in the horizontal direction, you sum in the vertical directions. So horizontally, I'll say my horizontal component, we'll say it's my Rx. Usually, if the final vector is R, we call it the Rx component. That's going to equal, just these two vectors are just going to add on top of each other. So I'm just going to simply do 20 cosine 40 degrees plus 12 sine 20 degrees. And when I do this, 20 cosine 40 plus 12 sine 20, I get 19.4. Okay, really it's 19.4. You got to remember though, this is 19.4 to the left. And R sub y, well, let's see. I'm ultimately going to go down. So I'm going to say, well, this is the 20 sine 40 degrees. But I'm going to subtract this one because this one's going north. Minus 12 cosine 20 degrees. And so I do 20 sine 40 minus 12 cosine of 20. Make sure I enter that in right. And I end up with 1.6. Okay. Okay, good. So these are in meters. And so last is I just need to find the length of this at this point. Okay, so the magnitude of R, the magnitude of this vector is the square root of the x component squared plus ry squared. Because it's just like before, what we're going to do is we have a vertical component and a horizontal component, and that's what we've ultimately summed up. This is r sub y and this is r sub x. And so r, because if this is a really small right triangle, but this is a right triangle nonetheless. So I'm going to do square root 19.4 squared plus 1.6 squared. And I get 19.5 meters. Which kind of makes sense because it's mostly in the x direction. Now the angle that we would talk about, this angle, I think they want it with respect to here. So if I think about it, the opposite side of this right triangle, like this theta is equal to this little angle right here. This is theta right here. So tangent of theta would be ry over rx. So theta would be tan inverse of ry over rx. And if I do that in my calculator, tan inverse of 19.4, 1.6 divided by 19.4, I get 4.7. Okay, and that's it. It's 4 point degrees, and we would say this is south of west. Okay. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.